Calcium sulfate, or calcium sulfate, is the inorganic compound with the formula calcium sulfate and related hydrates, in the form of γ-anhydrite, the anhydrous form. It is used as a desiccant. One particular hydrate is better known as plaster of Paris, and another occurs naturally as the mineral gypsum. It has many uses in industry. All forms are white solids that are poorly soluble in water. Calcium sulfate causes permanent hardness in water, hydration states and crystallographic structures. The compound exists in 3 levels of hydration corresponding to different crystallographic structures and to different minerals in the nature. Calcium sulfate, anhydrite, anhydrous state, calcium sulfate 2H2O, gypsum, dihydrate, calcium sulfate 0.5H2O, basanite, hemihydrate, also known as plaster of Paris. Specific hemihydrates are sometimes distinguished: alpha hemihydrate and beta hemihydrate. Uses: the main use of calcium sulfate is to produce plaster of Paris and stucco. These applications exploit the fact that calcium sulfate, which has been powdered and calcined, forms a moldable paste upon hydration and hardens as crystalline calcium sulfate dihydrate. It is also convenient that calcium sulfate is poorly soluble in water and does not readily dissolve in contact with water after its solidification. Hydration and dehydration reactions. With judicious heating, gypsum converts to the partially dehydrated mineral called calcium sulfate, hemihydrate, calcined gypsum, and plaster of Paris. This material has the formula calcium sulfate, NH2O, where 0.5 and 0.8. Temperatures between 100 degrees Celsius and 150 degrees Celsius, 302 degrees Fahrenheit, are required to drive off the water within its structure. The details of the temperature and time depend on ambient humidity. Temperatures as high as 170 degrees Celsius are used in industrial calcination, but at these temperatures γ-anhydrite begins to form. The heat energy delivered to the gypsum at this time, the heat of hydration, tends to go into driving off water as water vapor, rather than increasing the temperature of the mineral, which rises slowly until the water is gone, then increases more rapidly. The equation for the partial dehydration is calcium sulfate 2H2O calcium sulfate 0.5H2O plus 1.5H2O. The endothermic property of this reaction is relevant to the performance of drywall, conferring fire resistance to residential and other structures. In a fire, the structure behind a sheet of drywall will remain relatively cool as water is lost from the gypsum, thus preventing or substantially retarding damage to the framing. Through combustion of wood members, a loss of strength of steel at high temperatures, and consequent structural collapse. But at higher temperatures, calcium sulfate will release oxygen and act as an oxidizing agent. This property is used in aluminothermy, in contrast to most minerals, which when rehydrated simply form liquid or semi-liquid pastes, or remain powdery. Calcined gypsum has an unusual property. When mixed with water at normal ambient temperatures, it quickly reverts chemically to the preferred dihydrate form, while physically setting to form a rigid and relatively strong gypsum crystal lattice. Calcium sulfate 0.5H2O plus 1.5H2O calcium sulfate 2H2O. This reaction is exothermic and is responsible for the ease with which gypsum can be cast into various shapes, including sheets for drywall, sticks for blackboard chalk, and molds to immobilize broken bones, or for metal casting. Mixed with polymers, it has been used as a bone repair cement. Small amounts of calcined gypsum are added to earth to create strong structures directly from cast earth. an alternative to adobe, which loses its strength when wet. The conditions of dehydration can be changed to adjust the porosity of the hemihydrate, resulting in the so-called alpha and beta hemihydrates, which are more or less chemically identical. On heating to 180 degrees Celsius, the nearly water-free form, called γ-anhydrite, calcium sulfate and H2O where N equals 0 to 0.05, is produced. Γ-anhydrite reacts slowly with water to return to the dihydrate state, a property exploited in some commercial desiccants. On heating above 250 degrees Celsius, the completely anhydrous form called beta-anhydrite or natural anhydrite is formed. Natural anhydrite does not react with water, even over geological timescales, unless very finely ground. The variable composition of the hemihydrate and γ-anhydrite, and their easy interconversion, is due to their nearly identical crystal structures containing channels that can accommodate variable amounts of water, or other small molecules such as methanol. Other uses. The calcium sulfate hydrates are used as a coagulant in products such as tofu. Up to the 1970s, commercial quantities of sulfuric acid were produced in Whitehaven, Cumbria, UK, from anhydrous calcium sulfate. Upon being mixed with shale marl and roasted, the sulfate liberates sulfur trioxide gas, a precursor in sulfuric acid production. The reaction also produces calcium silicate, a mineral phase essential in cement clinker production. Calcium sulfate plus silicon oxide calcium metasilicate plus SO3. When sold at the anhydrous state as a desiccant with a color-indicating agent under the name diorite, it appears blue, anhydrous, or pink, hydrated, due to impregnation with cobalt. 2. Chloride, which functions as a moisture indicator. Production and occurrence. The main sources of calcium sulfate are naturally occurring gypsum and anhydrite, which occur at many locations worldwide as evaporites. These may be extracted by open cast quarrying or by deep mining. World production of natural gypsum is around 127 million tons per annum. In addition to natural sources, calcium sulfate is produced as a byproduct in a number of processes. In flue gas desulfurization, exhaust gases from fossil fuel power stations and other processes, e.g., cement manufacture, are scrubbed to reduce their sulfur oxide content by injecting finely ground limestone or lime. This produces an impure calcium sulfite, which oxidizes on storage to calcium sulfate. In the production of phosphoric acid from phosphate rock, calcium phosphate is treated with sulfuric acid and calcium sulfate precipitates. In the production of hydrogen fluoride, calcium fluoride is treated with sulfuric acid, precipitating calcium sulfate. In the refining of zinc, solutions of zinc sulfate are treated with lime to co-precipitate heavy metals such as barium. Calcium sulfate can also be recovered and reused from scrap drywall at construction sites. These precipitation processes tend to concentrate radioactive elements in the calcium sulfate product. This issue is particular with the phosphate byproduct, since phosphate ores naturally contain uranium and its decay products such as radium-226, lead-210 and polonium-210. Calcium sulfate is also a common component of fouling deposits in industrial heat exchangers, because its solubility decreases with increasing temperature. See the specific section on the retrograde solubility. Mars. 2011 findings by the Opportunity rover on Mars show a form of calcium sulfate in a vein on the surface. Images suggest the mineral is gypsum. Retrograde solubility. The dissolution of the different crystalline phases of calcium sulfate in water is exothermic and release heat, decrease in Gibbs free energy, delta G less than 0. As an immediate consequence, to proceed, the dissolution reaction needs to evacuate this heat that can be considered as a product of reaction. If the system is cooled, the dissolution equilibrium will evolve towards the right according to the Le Chatelier principle, and calcium sulfate will dissolve more easily. The solubility of calcium sulfate increases thus when the temperature decreases. If the temperature of the system is raised, the reaction heat cannot dissipate and the equilibrium will regress towards the left according to Le Chatelier principle. The solubility of calcium sulfate decreases thus when temperature increases. This contra-intuitive solubility behavior is called retrograde solubility. It is less common than for most of the salts whose dissolution reaction is endothermic, i.e., the reaction consumes heat, increasing Gibbs free energy, delta G greater than 0, and whose solubility increases with temperature. Another calcium compound, calcium hydroxide, CaO2, portlandite, also exhibits a retrograde solubility for the same thermodynamic reason, because its dissolution reaction is also exothermic and releases heat. So, to dissolve higher amounts of calcium sulfate or calcium hydroxide in water, it is necessary to cool down the solution close to its freezing point in place to increase its temperature or to use nearly boiling water. The retrograde solubility of calcium sulfate is also responsible for its precipitation in the hottest zone of heating systems and for its contribution to the formation of scale in boilers, along with the precipitation of calcium carbonate whose solubility also decreases when CO2 degases from hot water can escape out of the system. See also calcium sulfate. Data page. Alabaster. Anhydrite. Bathybius Hakeley. Chalk. Calcium carbonate. Gypsum. Gypsum plaster. Phosphogypsum. Flue gas desulfurization. International Chemical Certify Card 1215. NIOSH Pocket Guide to Chemical Hazards.